Everyone, welcome back to Pine Hollow Auto Diagnostics. Silhouette Chronicles, a little bonus series. Got the dash torn apart and the cluster is out. This thing needs some work on the instrument cluster. So here it is on the bench, and we got a whole bunch of goodies set up. Signal generator, the Pico scope, brand new laptop. We're gonna have some fun. Ooh, that's right, we're gonna do some bench testing. So this cluster, every gauge on here almost has issues. Starting on the left, the voltmeter. We're at 13 volts right now. That's the power feed. So I got powers and grounds hooked up. It's showing 15, so out of calibration. Oil pressure gauge, obviously it's not hooked up to the vehicle. We'll assume that's more or less correct. Tachometer seems to be doing fine. The speedometer, when I took it on the maiden voyage, it seemed like it was out of calibration. So we'll have to figure out how to match up the input from the car or our signal generator to the actual speed. And then this tachometer and trip meter. Remember, it wasn't counting the miles correctly. It was like at least 10% behind, even less. We were not sure about the odometer, didn't really check that, but we can also do that with the bench test. Fuel pressure gauge works fine, but that stupid orange light stayed on, so I just took out the bulb. We're not going to worry about the logic behind that. It's controlled by a little chip and a transistor, so that would take too much time and effort to figure out for a stupid orange light when you can just look at your fuel gauge like any other car. Temperature gauge is also a bit out of calibration. I don't know if we'll get that far, but you know, let's start with what you know, the most interesting stuff. So I'm basically worried mostly about the trip meter, speedometer, maybe if we can figure that out, and the voltmeter. We should be able to figure out how to recalibrate that needle. So what is the setup with the speedometer? How does this thing work? What does it need? What kind of input does it get from the speed sensor? So here is a diagram of the cluster, and here's our speedometer, power, ground, and C vehicle speed sensor. So we're not sure what this signal is. I'll show you how I found out. Alright, so how does this speed sensor work? So this is the main PCM schematic, and right here is our vehicle speed sensor. Two wires, yellow and purple, go to our powertrain control module. From there is a dark green wire, just a single wire, going to cluster speedometer, just one wire. So this thing basically has a VRS type sensor on the transaxle. The PCM reads that speed, and it sends a digital square pulse, 4,000 pulses per mile. That is the calibration. And how do we know the levels? Well, you know, I hooked it up to the car with a scope, just rolled it, and you can see square pulses 0 to 5 volts. That's all we need to know to do the bench test. Now, on the signal generator, we definitely want the square wave, and here's our frequency in hertz. See the little hertz button is lit up. So the actual signal right now is, let's see if we hook our oscilloscope to the signal coming from the signal generator. There it is. So 0 to 5 volts, and the frequency is whatever we set it to. Now we want to figure out, let's do a little math. This is our given value, 4,000 pulses per mile. Now, what do we run the signal generator if we want to, say, run the speedometer at 60 miles an hour? Right? What's the conversion? So, just look at your units. The units kind of do the work for you. The frequency equals the velocity in miles per hour times that conversion factor, 4,000 pulses per mile, but the hertz is in cycles per second instead of hours. So all we have to do is figure out how many seconds are in 1 hour. So there's 60 minutes in 1 hour and 60 seconds in 1 minute. See all the units cancel out, hours cancel out, miles cancel out when we have pulses per second. We crunch the numbers, and the frequency in hertz equals the velocity in miles per hour times 1.1. Since this is 4,000 and this is 3,600, so it's actually pretty close. The frequency here is going to equal the miles per hour times 1.1. So let's say if we want to go 60 miles per hour, it's going to equal the well, the unknown is the frequency, so unknown F equals 60 miles per hour times 1.1. Okay, so that equals 66 hertz. So if we set this thing to 66 hertz, we'll dial it up. Let's see, 66, right about there. We're showing now about 63 miles per hour. It should be showing exactly 60. So that's about 3 miles per hour too high. We can ramp it up to like 88. And this should show 80 miles an hour. And it shows about 82. So not terrible. You know, actually it's pretty well calibrated according to that 4,000 pulses per mile signal. And again, we're not sure that the vehicle is sending out exactly 4,000 pulses per mile. I mean, it has the OEM tires on it, the size, and it's all stock, so there's no reason it shouldn't send that signal, but that is a variable. But we do see that the speed is pretty well calibrated. Now, what about this trip meter and the odometer? How can we quickly check that the miles are rolling over at the correct pace? Well, if we set the signal generator to output a speed or a signal that's equivalent to 120 miles per hour, then we're going to get 2 miles per minute rolling on our odometer and the trip meter. So we can clock a minute using our handy stopwatch on the computer. So reset that. And let's set this thing to, so 120 miles per hour times 1.1 is equal to 132 hertz. So we're going to overclock the speedometer. Obviously it's pegged out. The miles should start rolling pretty quickly. So let's wait until the odometer rolls over that 8 and start our stopwatch. I'm going to reset this guy right at 1 minute. Which is love the miles roll, watch the miles roll by. So look at that, switch the mile, it's only a 9/10. That's our 10% loss of accuracy. So it looks like the odometer is counting fine. So that is the original mileage of the vehicle. However, the trip meter, once in a while, you'll see the numbers actually not turn, kind of skip. So it seems like a mechanical problem with the gears just on that trip meter. See, there's a 3 and that right there. It's basically stuck and it's like, and here we go. So now it's going to be off by like 2/10 of a mile or more. When that 4 rolls over, this isn't going to be on 3. Right there, 4, and that's barely at 8/10. So it's already 2/10 behind. And we're at 2.5 minutes. So the miles count well enough, but the trip meter has issues. Sometimes it gets stuck and something in there kind of snaps and grinds, so little plastic gears might be worn out. In the actual system here, it's interesting. There's a electric motor, it's a stepper. It spins. Let me turn my light on. Spins this gear right here, and it's driving a big gear, which drives the 2 gears of the odometer and the trip meter. So there's nothing wrong with the motor. There's nothing wrong with this big gear. I mean, it's a little loose, but it doesn't skip here. It just skips inside of there. Where it connects to the trip meter. So I guess they definitely solved this problem when they went to the digital odometer and trip meter. And there's just an LCD screen. There's no more gears and motors and little things to wear out, you know. But anyways, I think it's pretty neat to play around with the old stuff too. So we have to tear this cluster apart and look at the gears inside for the trip meter and see why it's skipping sometimes. So this cluster is kind of interesting. The only thing that really holds it down is that pin tension between the gauges and the circuit board. So you just kind of have to work it. Speedometer, tach. And it's pretty cool that it has gauges for oil pressure and volts and stuff, unlike the Japanese. But you know what? On the Japanese clusters, we never have these issues, right? Alright. So the little connector there was for that stepper motor. And all the good stuff is on the circuit board. Alright, I got the cluster a little more torn apart. Here is our odometer and our trip meter. So what we're worried about is from this gear to this row of numbers, something is clicking, sometimes doesn't catch, doesn't engage. So what I want to do is take this big plastic transfer gear out. It looks pretty easy, just a little plastic nib right there, and then we'll just mess around with this guy and see what we can fix. Alright, this is pretty neat how this thing works. I've always wondered how the magic button resets all the numbers. What happens there? So as we're driving down the road, you can see this white gear. That is the key player, this guy right here. What it does is it connects the black gear all the way on the side with the white gear of the tenths of the miles. And if everything's good, things roll along and the black gear stays connected to the white gear through this little tiny white gear, you see it's split 50-50 black to white, and if it's pushed away by the big button, then the black gear spins without touching the tenths. See, it's disengaged. The only thing that engages them together is that white gear. It keeps rolling, and then the green ones are actually connecting all the numbers together. So every revolution of the white ring, a notch comes around and turns the green, you know, a tenth of a turn, which turns the corresponding number, you know, following it. And it keeps going, and boom, there it goes again. Another thing to note here is that black gear, it's cracked. So actually all these gears look a little fragile, but if that gear is cracked, then the tooth spacing in there, you can see that tooth is actually wider than the white one next to it. So when that white gear comes through, it'll jam up, wear out. Not a good situation. What we could try to do is take this whole shaft out and see if we can at least glue that black gear tighter onto the shaft so there's no gap. Kind of take it from there. Well, I'm thinking, since the plastic got dry and brittle and kind of expanded, pressing it back together and gluing it might not be the right solution. What I want to do is actually take it off the shaft, glue it, and maybe drill the plastic out just a little bit so the interference fit isn't as tight, and then super glue it onto the shaft in that exact spot. That way there won't be as much stress on the plastic trying to, you know, bust it apart. So yeah, it's worth a shot. So for welding plastics, I like to take a metal implement, heat it up with a propane torch, and see if you can melt the plastic. So see how it goes. Actually, that worked pretty well. Let's see if it actually fit on the shaft now. Let me run the drill through it one more time just to be 100% that it's sized right. Looks pretty decent. Alright, it's on there. It's tight. I don't think it's going to crack anytime soon. Let's just put all the numbers back on. Like so. And then this little keeper. It's just a spring, 2 little bushings. Now, we'll pop it in here. Hopefully the alignment is good. Snap, snap. Alright, here we go. So this way. Is it working? I think. So that white gear, it's basically not engaging very well with the that guy. All right, victory with the trip meter. It works. Here I'll demonstrate. Camera set up here. So here it is. So it goes this way. 1, 2, 3, roll the miles, and then boom, resets perfectly. So what was the fix? Step one was to glue this black gear back together, or rather melt the plastic back together. So it's on there, it's tight on the shaft. The other problem was this little white intermediate gear back here that connects the black drive sprocket to the 10th digit on the trip meter. That thing was not engaging very well. It was just worn, and not only was it worn, this whole shaft, it's kind of a silly design. You know, when you reset the trip meter, the whole shaft comes back and the numbers reset, and when you release the button, you see the spring in there, retracts the shaft. However, it's not balanced. The shaft is being pulled by that black plastic lever, and the stop is this one spot on, you know, the body on the blue plastic. So that kind of makes the shaft pivot, kind of like a lever, like this, and pulls the white gear away from where it's supposed to be. And with, you know, wear and tear, everything has a little play in it, and that gear just was not making a good mesh contact to those two pieces. And that gear is key. It basically meshes the drive gear to the 10ths. So what was the solution? Well, I'm like, well, how do we push that gear in? I tried a piece of foam, a spring, and what I came up with was little elastics for braces. I inherited this from somewhere, I don't even know where. I just stuffed it in the rubber bands drawer just because I can't throw away things that could potentially be useful for something. This was years ago. So anyways, I stuffed a little elastic piece to this end of the shaft. I wanted to pull it that way. So the elastic just comes through, and I just wrapped it around the little blue housing there. It's out of the way, it's not rubbing on anything, and the reset still works. You can see the elastic being pulled. You know, there it is. Beautiful, right? Everything meshes. All the numbers go in sync. Let's see if we line up the zeros. Reset. 0. 0. 0 again. So perfect. The trip meter works. All we need to do now is pop this thing back in the cluster. Alright, here we go. Power supply on. Get it to 13.0 volts. Now, frequency. We'll dial this guy up to 60 miles an hour, which is 66. Sweet. Hey, look. The odometer is working. So, let's adjust the needles for the voltmeter. I am going to try does the needle come off? It does. Whew. Okay, I'm happy with that. 13 is 13. Finally. That's 10.5. That's right at 13. And that second mark is going to be 15.5. Perfect. I like it. So when the car's running, it should be right around there. Around 14 volts. Alright, now the speedometer. So we're at 66 hertz. We're showing 63 miles an hour. It should show exactly 60. Let's correct that. Hopefully I can... Oh my gosh. I'm gonna break something here. Alright, right at 60. Good. Let's go up to 80, so that'd be 88. And right on the money, that'd be 110. I'd say that's close enough. The last thing is the temperature gauge, remember? It was not really reading 200, but I'll leave that alone. Voltmeter works, speedometer works, trip meter works beautifully. I think we're ready to install this back on the car. Man, that was a long project. Alright, drove the van to work. Cluster works perfect. The speed is right on the money. The odometer, so I clocked the miles using a GPS. 10.6 miles to get to work. And on the odometer it says 10.9. So now it's counting a little fast. 0.3 miles for every 10 miles it overcounts. So if you go 100 miles, you'll be 3 miles over. So I guess 3% too fast. Again, at least it's consistent and it's pretty close. So I think it's as good as we can get it here. So that's it for this extra bonus part. And stay tuned for more. I don't know if someone's gonna buy this thing soon, but we'll keep working on it until they do.